3, where we're going to talk about contingency tables. Essentially, what that means is we're finding relationships among categorical variables. And calling the categorical variables can be either nominal or ordinal, but that's what we're dealing with in this lecture. Relationships. Relationships 101. Didn't know you were going to talk about relationships in a class like statistics, now did you? Well, a person's attitude or belief about a particular public policy is contingent upon their other beliefs and life experiences. For example, abortion policy has been presented as a feminist issue, a religious issue, and an ideological issue. What that means is a lot of words, but what that essentially means is, as a researcher, you'd want to include those variables related to the issue, such as gender. If it's a feminist issue, then let's see whether men think differently about the issue than females. If it's a religious issue, well, let's see whether it be a Muslim or atheist or Christian or Buddhist, whether that has anything to do with their opinions about abortion. And then in terms of political ideology or even political party, right, let's see whether Republicans, Democrats, Green Party, and so on think differently about this issue and whether being conservative or liberal or somewhere in the middle has anything to do with it. Alright, so all of these variables could possibly affect one's attitude on whether women should have the freedom to choose an abortion, to choose to abort a child for any reason. These are all hypotheses, guesses. We'll talk a little bit more about this in a future lecture, but just understand that these are hypotheses or guesses about relationships between these particular variables, gender, religion, and so on, and one's opinion about abortion policy. The researcher could argue, for example, that one or more of these reasons, the independent variable, influences one's beliefs about abortion, the dependent variable. So in this study, we're looking to see whether, and I use this term very loosely, because we don't necessarily talk about causality unless we have a very rigorous type of study, which we call experiments, where we can really control factors and determine whether something causes something else. But for this explanation, we're going to say cause and effect, just to be very simple in our terms, but essentially whether one is associated with the other. The independent variable being what might be causing or what might be associated with one's opinion about abortion, which is the dependent variable. It's dependent on maybe your religion or your gender or your political ideology, right? It's dependent on those things, and that's what we want to study in that, or that's what that researcher would want to study, right? In that research. So again, the independent variable is what we very loosely consider the cause, and the dependent variable would be what we're considering the effect of that cause, that independent variable. The differences or changes in an independent variable lead to differences or changes in the dependent variable. That's essentially what that first line is. We're just restating in a different way. So when two variables are related, okay, when two variables are related, observations with different values on the first variable tend to have different values on the second variable as well. I know that sounds like a lot, but let's give an example of it. If gender and abortion attitudes are related, so if these two variables are indeed related, then one sex or one gender, say males, will be more likely than the other gender, females, to support pro-life. Okay? And so let's give an example of relationships between political party and universal health care. What would one relationship or one guess be about what the relationship might be? We could say something like one's political party might have an effect on their opinion about universal health care. But more specifically, because that's still very broad, we might say that Democrats might support universal health care more than Republicans, something like that. That would show us some type of relationship. Now, if if Republicans had the same exact views as Democrats on universal health care, then we would say there is no relationship. There's no relationship between political party and universal health care because Republicans and Democrats think the exact same way, have the same opinions about universal health care. Now we know in real life that's not the case, right? But we could say that if we saw that Republicans are having the same views as Democrats, then there would be no relationship. Just like in the first example, we would say if males and females were saying abortion is terrible, if they're both saying abortion is terrible, then there's no relationship between gender and abortion attitudes. But if we're saying if more males are saying, oh yeah, abortion is bad, and more females are saying abortion is good, then whoa, there's something there, something's happening there, and we can see that there's a difference in gender opinions, and so there might be a relationship between gender and abortion attitudes. Okay? So one way to test whether relationships exist between categorical variables is to separate frequency tables, is to run, separate frequency tables for each value of the independent variable. Okay? So remember from lecture 1 that nominal and ordinal are both categorical variables. And so what we're going to look at now is not a frequency, it's a frequency table, but because we're looking at relationships, we kind of have to take it up a notch. It's a frequency table sort of on steroids, okay? The frequency table, we would see only one variable. We would see, in this case, our variable is abortion attitude. So, abortion if women want for any reason. That's the name of that particular variable, which is kind of long, so they've shortened it to that ABANY, abortion for any reason. And at the top, you see that they only looked at males. At the bottom, you see that they separated and only looked at females. Okay, so a frequency table allows us to separate and look at, okay, well, in this table at the top, we see that 97 of the men in this survey said yes, abortion for any reason. 145 of the men said no abortion for any reason. We'll agree with it. And we can see that 242 of our valid responses were men. At the bottom, we can see that the total valid responses are 382 for females. And so if we add that up, right, we could create, essentially, we could create a table, frequency table that just said that had both males and females. We could clump it all together, but the researchers said, yeah, I want to see them separately. I want to see what males said and what females said. Now this is okay. This is an okay way to do a table, and to compare. And we can see that 148 of them, or excuse me, let's look at the relative frequency. We can see that 38% or 38.7% of the females say yes to abortion for any reason. 40% of the males said yes for any reason. It's pretty close. So because we're seeing that they're so close, we might say, well, I guess they don't really differ in their opinions. So gender might not play a major role. Okay. We looked at the frequency tables, and we have to look at frequency tables first and understand ourselves first The way I say this about relationships 101 is that we can't get into a relationship until we understand ourselves. And a word to the wise, I would say, don't get into a relationship until you know yourself first. And so that's why in week one and week two, we were able to know ourselves. We were able to understand how to describe a data set and how to describe one variable only. Now in lecture three, we're able to get ourselves, you know, in a relationship. we're able we're able to look at two variables at one time, two different variables at one time. And as you remember, frequency tables and charts help us to simplify data and help us to demonstrate patterns easily. And today, we're taking it to another level and looking at contingency tables because relationships are complicated, guys. They're complicated. But if you don't know how to deal with a relationship by yourself, you're not going to know how to handle that second person, right? And in this case, that second person is the second variable. So when we are trying to understand relationships, contingency tables help us to further simplify the data, and they provide even more data. So let's take a look at that. Alright, so here's a contingency table. In this case, we are looking at our two variables, again, opinions on abortion, and then as our dependent variable, which we'll always see on the right, that's the left, on the left column. And then our independent variable, we have various categories here: conservative, moderate, and liberal. And for opinion on abortion, we have no, maybe, and yes, pro-life, depends, and pro-choice. Okay, so we just created a contingency table rather than look at all of these in frequency tables. And essentially, it would be a lot of frequency. It would be three frequency tables looking at this one versus looking at this one contingency table. Okay, just like with the previous couple slides back, we looked at two frequency tables for opinions on abortion and gender. So we looked at one table that said male, one table that said female. In this case, we would have been looking at three tables: one for conservative, one for moderate, one for liberal. Okay? The row percentages. So again, this is the frequency table and what it looks like. We can see 2,118 people were conservatives who said no to abortion. We see that 899 people responded that they are moderate and they are pro-choice. And then we can see, let's go all the way over to 3,680 people of the total respondents saying, it depends, maybe, I don't know, who knows, right? 3,680 people said, I don't know. And so for every number here, we can go across and down, and we can see what that number means. So 733, we go up, we see that means conservative. We go across, and we see that means pro-choice, right? But now let's look at what the row percentages mean. Row percentages talk about should always show you 100% at the extreme right. So all of the percentages that you calculate, if you add them all up, they should equal 100. Always, when you count them across. Okay? So in order to get the row percentage, what we do is we take the number, let's start with 2118, and we divide it by the total for that row. Total for that row is 2716. Okay? 2118, you divide it by 2716. because that's the total at the end of that row. Remember, rows go from left to right, columns go up and down, up and down. Okay, so for row percentages, so for example, another example, if we wanted to do the row percentage of that 1067, the row percentage would be 1067 divided by 3680, and so on and so on. That's how you calculate row percentages. And now let's interpret this row percentage. Okay, so 78% of, and this is important, I've underlined it here because this is critical. This is absolutely critical. After the word of, you have to talk about what the total is for that row. 78% of, and that means whatever we just divided by, 2716. Okay, so what's that row is pro-life. Okay, or the people who said no. So 78% of the people who said no are what? Conservative. After the word of, it always has to follow whatever we divided by, whatever that row is about. That row is about pro-life. So another way we can say it is 78% of, we're not saying said no anymore, we're just going to call it what it is, of the pro-life respondents, and then we end it the same way we did earlier, are conservatives. So 78% of pro-life respondents, or 78% of the people who said no, are conservatives. So we took all 2,716 people, took them, put them in a room, and we said, of that total 2,716, everyone who's conservative, please raise your hand so we can see you. We counted it, and it ended up being 2,118. That is about 78% of the total number of people in that room. I hope that's coming together in your head. Hopefully that's making sense to me. I just described it. If it is, then let's move forward and answer the next question. What percent of respondents who said yes are conservative? So, as we did before, what comes after of, that means that was our denominator, that is the bottom. So, who are conservative? Let's go to that conservative column, and let's go to where it intersects with yes. That's 733, which means we divided it by the end of that row at 2,365. So we take that percentage, and we get 733 divided by 23765, and we get 31%. So about 31% of pro-choice people are conservative. And so let's do it for what percent of the undecided people are moderates. What percentage of them are moderates? Well, we can see, we don't even have to, we could calculate it, of course, and we would calculate it by going to where moderate and maybe intersect. That's 1,067. And we would divide it by 3680. Or we can go to the bottom chart where it says 29. Okay? So we see that 78 corresponds to the 211. It's in the very same exact location at the top and the bottom. 2118 is in the same location as 78. 733 is in the same location as 31%. And then 1067 is in the same position at the bottom with 29%. Isn't statistics fun? Again, but this time we're going to look at column percentages. Alright, so let's start with that same example of conservative pro-life folks. Conservative pro-life. So 41% of, again, that, this time we're looking at columns. So we're going to, our total has to be at the bottom. First off, we know that for columns, for rows, our 100% had to add up all the way across. In this case, you can try to add up those numbers all the way across, and you'll notice that they don't add up to 100. So these are column percentages, because if you add them down, you'll get 100. 43.1 plus 42.0 plus 14.9 should give you 100%. So we're dealing with column percentages. And so going back to our example, 2118, and we're looking for the column percent, so we're going to divide it by the total at the bottom of that column. So we took 4,912 conservatives, put them in a room. We said, all right, raise your hand if you're pro-life, or if you said no to abortion. If you're pro-life, raise your hand. So of the and remember, as I said, of the 4,912 people in that room, how many people raised their hand? 2,118. So we did basic division that we learned in middle school, probably elementary school. 2118 divided by 4912, and we got 43%. So notice that 43.1 is at the top, where the conservative and pro-life intersect. We're going to see that all the way across, okay, throughout the top and bottom tables. So 41% of all those conservatives said are pro-life. 41% of the conservative respondents are pro-life. So what percentage of the conservative respondents are pro-choice? So we're still in that column, apparently, of conservative people. We're in that room where it's only conservatives in there. And we said, all right, raise your hand if you're pro-choice, if you say yes to abortion. And then we go into a room full of moderates and we say, hey, raise your hand if you are unsure, if you're undecided, right? And so how do you calculate those numbers, those percentages? Well, the first one, our room is full of 4,912 conservatives, and we want to know which is what the percentage of pro-choicers are. That's 33 divided by that total. So about 15% said they're pro-choice. And then we go into the moderate room and we see 2,401 people in there, and 1,067 were kind of on the fence. So 44% said that they are unsure moderates. Okay? We've got that same table again. Don't get tired of looking at it, because it's helping us really understand contingency tables. But this time, we've got total percentages. So just to recap, our column percentages allow us to calculate. We take everything in that column, put it in a room, and then we ask them, okay, what do you think about this thing, whatever that dependent variable is? Okay, our row percentages is we take everyone in that row and we say, all right, are you are you conservative? Are you moderate? Are you liberal? Okay, so that's your row percentages should add up to the 100. Yes, 100 across. Okay, from left to right, those numbers should add up to be 100%. Going for column percentages, all the numbers straight down, one beneath the other, should add up to be 100%. Okay, so that's a quick and easy way to always know whether you calculated something correctly, because if they're not added up to 100 across or 100 down, then you may have done something wrong to calculate that row or column percentage. Now, we've got total percentages. Guess what that might mean? So with our row percentages, it was the total at the end of the row, whatever that row was. For the column percentages, it was the total at the end of that column. So the total percent, though, is the total of the entire sample. Okay? So in this case, we have how many observations? You should have guessed. You don't have to guess. You should see that the total number of observations is 8,761 people responded to these questions. 8,761 people responded. Okay? Now there are some missing values, but the beauty of contingency tables is that these are all valid responses. We don't have to think about the missing responses. We don't have to think about the system errors, those type of things, because contingency tables only say, all right, let's just see what's most important, what the valid responses are. So yeah, we had 8,761 people that provided valid responses, but there were probably maybe more people in the sample that just didn't answer. Maybe they left out whether their political ideology, or maybe they didn't respond to the abortion question. So for whatever reason, they are missing, and so we couldn't put it on the table. All right. So total percentages deal with that total at the very bottom right hand side. Okay. So if you add up all those row percentages, you should get 8761. If you add up all the column percentages, 4912, column totals, 4912, 2401, 1448, that should all equal 8761. If you add up all the column percentages, 2716, 3680, 2365, that should all add up to 8,761. Okay? Now let's calculate. So if we use column percentages as our bottom number, our denominator, and we use column totals, and we use row totals for our denominator for row percentages, then we're going to use the total is what I like to call it, for all of our total percentages. So let's go back to that one example. Conservatives who are pro-life. We're going to use that same number because they're conservatives who are pro-life, and it's 2,118 people. And what percentage of all of the respondents are conservative pro-lifers or pro-life conservatives? So we divide that number by 8761, and we get 24% of the total number of people that are in the sample are pro-life conservatives. What about the percentage of people who are pro-life? Well, we see the number of people who are pro-life. That number is 2716. So whether you're conservative, moderate, liberal, the total number of people who said, I'm pro-life, that's 2716. We take that number, we divide it by the total, which is 8761. So we get about 31% of people said that they're pro-life. Okay? Total percent of conservatives in this survey is 56%. So the conservatives, we go down the column, we see the total number of conservatives is 4612. Okay? And we divide that by the total, 8761. So about a little over half of the respondents are conservatives. What percentage of the total respondents are pro-choice? I'm going to let you do that. And what percentage of the total sample are unsure liberals? I'm going to give you a second to do that. So you might want to pause it right here because we're about to give you the answer if you haven't already gotten it. Okay. 2365, that's the total number of people who are pro-choice, right? And you divide that by the total. Okay, so unsure liberals, that's 552, and divide by the total, so about 6%. All the percentages are used, actually they are considered the way that people can understand whether a relationship exists. Okay, and so we tend to look at the extremes, and so we don't tend to look at the moderates. We either look at the conservative or the liberal, because whatever happens in the middle tends to be a little murky. So what is the conservative trend telling us? And you notice the arrow I placed there. So we can see that for conservatives, they get more pro-life as they are more pro-life than pro-choice. They're more pro-life conservatives than pro-choice. Pro-life is about 15%. Pro-life is about 43%. Pro-choice is about 15%. What do we see in that last column? Liberals are doing the exact opposite, essentially, of conservatives. There are more pro-choice liberals than there are pro-life liberals. Okay, we can see that trend. Here's what we're seeing here with moderates. Okay, just like I said seconds ago, it's not the best, I guess, strategy to look at the middle categories. The middle categories can cause you to be a little unsure of what the trend might be. So we look at the extremes for this very reason, because it's kind of merging in the middle, which right it should, because they're already in the middle between conservatives and liberals. So we see that there's really no trend except for they say it depends more. They're unsure. They're more unsure, obviously, than the liberals and the conservatives. They're more unsure. So we stick as a rule of thumb, we stick to the extremes, the extreme ends. Relationships. So we've done it using column percentages, and now we're doing it using a graph. In this case, a line graph. We can see from this line graph that a lot of things are happening. We can see that you see the blue line is liberal, the moderate line, see the orange line is moderate, and they're sort of kind of doing the same thing. Sort of. Moderates kind of go up and then down, just like we saw in the chart, right? Just like we saw in the table. The conservatives are doing practically the exact opposite. So we see liberals going up and over, and the conservatives going sort of slightly down and under. When we see something like that, when they're not matching up, then we can see that a relationship exists. This is a key way, another key way of seeing that a relationship exists. It just confirms what we saw in the column percentages. Same thing here with the bar or column graph. Okay, we can see the trend for pro-lifers and the trend for pro-choicers, and they're literally opposite. One is going down, the other is going up. And then what's happening in the middle, again, is not much. Everyone's sort of on the same playing field. So using column percentages is a great way if you can't create a chart or graph. Is a great way to just kind of see the trend using these column percentages. We can see the trend for males is that males think that it's always wrong to have premarital sex, more so than not wrong, right? 64% versus 7%. And then for females, 78% think it's always wrong. And then about 2% think it's sometimes wrong. So in both trends, there are more people who think it's always wrong than there are who don't think it's wrong at all. Okay, they're doing the same thing, they're going in the same path, and to see this in the previous slide and in this visual slide, what can we conclude? Well, we can essentially say that gender doesn't really play a role in one's opinion of premarital sex. Slightly, but not enough to make a major issue about it. Men and women maybe not equally agree, but because it seems like women more so agree that it's always wrong, but generally speaking, we can see that they both sort of have very much higher percentage of people say it's always wrong, and the much lower percentage of people who say it's sometimes wrong and it's not wrong at all. Okay? So no relationship here, because they're kind of doing the same thing. More examples, we see that same um, relationship. Lost my words there. See that same relationship, and you can see the trend being same things, right? So there's really no relationship. Charts, when graphing, we use relative frequencies rather than absolute frequencies. So what does that mean? Use percentages rather than numbers. And why? This is really key, not just to take my word for it, but to understand why. When you have relative frequencies, you have kind of standardized it, and you're taking it out of 100% absolute frequencies. If you have, 300 women in a survey and 100 men in a survey, and you're doing absolute frequencies, then if 100 women said something and all of the men said something of the same exact thing, you would say, oh, they think the same about it, but they don't. 100% of men think one way, whereas only 30% of women think that same way. So that is why it's important to use relative frequencies when we're graphing, because we need to be able to see it on the same scale, the 100%. The percentage is really important. The height of each line should always add up to 100. Okay? Focus on how similar or different the lines are to each other. No relationship equals each of the lines are identical or at least very similar, as we saw just in the previous couple slides. And then strong relationships means that we see a pretty big difference in the lines, just like we saw with, I think it was ideology, liberal, moderate, conservatives, right, in terms of abortion. Based on what we just learned and our rule of thumbs about how to visualize frequency charts and graphing, what can we say here? What can we actually say about the relationship between political ideology or political views and sex before marriage? Opinions about that? Hopefully you're saying to yourself, wow, there might not actually be a relationship, because we see that liberals at the red and conservatives and the blue are sort of similar, and even the moderates, right? Moderates are very closely lined up with what's happening with conservatives. But generally speaking, across the board, we see opinions go from always wrong, almost always wrong, it goes down, it goes back up to the other two, strong, sometimes wrong, and then not wrong at all. So it's going up, down, up. So we're probably likely to say there might not be not much of a relationship here. Okay? Relationships are complicated. But guess what? We can get through it. We can simplify those relationships by not looking at frequency tables, but through contingency tables. Okay? Finding relationships among variables is arguably the most important task in data analysis. That is why we do what we do. We want to know what the relationship is between one variable and another. So some things to remember. If the percentages are not practically identical, very similar to each other, then there is a relationship between the two variables. Okay? The more the row or column percentages differ, the stronger the relationship between the variables. Okay? Why did I say row or column percentages and not total percentages? It's important, sort of, because the total percentages deals with the total. That total number is not telling us anything about the variable categories, right? It's just kind of telling us about the total. It's just helping us see what percentage of the total said this or that, but it's not allowing us to compare row or the dependent and the independent variables. Okay? So do not solely look at one category of the dependent variable, say one row all the way across, to understand a relationship. Look at the two extremes but not necessarily the middle category. So look at the first column, maybe skip that second or third column. Look at the last column, because liberal versus conservative, we want to see that dynamic. Male versus female, we want to see that dynamic, right? If you have strongly agree and strongly disagree, the stuff in the middle can be a little murky. So, or, we may not want to look at the neutral category. We may want to look at only strongly agree and agree. I would even suggest putting it together in one, and then look at strongly disagree and regular disagree, right? And put that together in one column. See the trend that might be obvious there. Okay. This is lecture 3. Feel free to review this lecture, but now you can open up exercise 3 and move forward. Fun.